Last time we talked about various transformations of the graphs, and we observed a few things. For example, if you have y equals f of x plus 2, what does this to the graph of the original one? It moves left by 2, right? Okay, what if you have plus 3? What does this plus 3 do? It moves up by 3. Okay, so if you add or subtract to x or to the function, the graph moves left, right, up, down. It's one of those four. Okay, and then we also learned another type where you have like f of, say, 2x. What does this do? From here to there, what does it do? Yeah, it shrinks in x direction by 2. Okay? Shrinks by 2. So maybe I should write this. Shrink by half in x direction. In other words, horizontally it shrinks. Yes.
And that's only when it's in the parentheses.
Yeah, when x is replaced by 2x, that's what happens. Okay. But what if you have y equals to 2 times f of x? Well, this 2 is not a replacement of x. This 2 is being multiplied to the function, right? Anything that's done to the function, it would make the graph behave as what you're doing to the function, right? So this is going to expand, except now you have to figure out if it's the horizontal direction or the vertical direction. Which way does this one expand? No, vertical. It's the value of the function, so it does this. Okay, so it's expands times 2 in y direction. Okay, so those are the few things that we learned last time. Yeah, so if you add something like this, you're modifying the function. The graph will behave how you would expect it to. You're adding the 3 to the values of the function, so all the values get raised by 3, therefore the graph will move up by 3. However, if you replace x by x plus 2, that's a replacement, right? If you substitute the variables, that would result in the opposite effect on the graph. Okay, so we can summarize what we've learned yesterday as how to move left, right, up, down. Those are called translations. And how to make it enlarged or expanded, or you compress it. Either one of those two. Those are the other kinds. Now, the type of transformations that we're going to talk about today would be reflections. Now, let me start with an example. And for this question, we'll kind of analyze the question in depth, but then at the end of the day, we'll come up with some easy way to do reflections, all right? Okay, so first, how do we graph x squared plus 2x? Well, first of all, we would need completing the square to draw the graph of quadratic equation. That's what we observed last time, right? If there was a constant, we would have moved to the other side, but there isn't any, so we just have to now figure out what to add here, right here, so that this right side becomes something squared. Okay, do you recall what the algorithm was? We're talking about some algorithm to complete the square. What was it? Yeah? Plus 1. How did you get 1 though? You take half of the middle and you square it. That's how you get the thing to add, right? So the algorithm for, I don't know where to write it. Maybe I should write here. So complete the square by half the middle coefficient, then square it. Yeah. Not the best way to do it. I don't like it. It's like memorizing some special algorithm, but it works. Okay? You get to use it a lot, so I guess it's worthwhile to memorize. I don't know. So, but anyways, what's the middle number? Middle coefficient? 2, right? Take half. What's that? 1. What's 1 squared? 1. So that's why you add both sides. Add 1. And if you do that, then this becomes something squared. What is it? X plus 1 squared. Okay. Because half of 2 is 1. That's where this 1 comes from. Okay. And now you subtract 1 to the other side to get this equation. With that, we can graph the function. So you start with y equals to x squared. This is y equals to x squared. Yes?
You might be asking a stupid question. You add 1 to both sides and then you subtract the 1 on the y side. How did you get -1? Shouldn't it be 0?
No, that's not what I did. Sorry. I'm skipping steps. That's why you're confused. So first of all, this became this. Is that okay? If you add 1 and if you factor this right on the right side, this becomes x plus 1 squared.
Oh.
Right? And then, after you've managed to complete the square, then you subtract 1. Okay? So you get y equals to x plus 1 squared minus 1. All right. Sorry, if I skip steps, some people end up being confused. Okay. And I like this format because what does x plus 1 squared mean? This y equals x squared is moving which direction? 1 to the left, right? What does this do? 1 down. So this vertex that you had is going to move 1 to the left and then 1 down, which means now the new vertex is over here, so that the graph of the new guy is like that. Is that okay? Okay, move 1 step left, 1 step down. That's the graph. Okay, so that part is done. That first part is done. Sketch the graph of this. Now the next part is find the equation of parabola obtained by reflection over the y-axis. So this parabola is now going to be reflected over the y-axis. This is your y-axis, right? This axis is y-axis. You're reflecting this over to this side, which means you're trying to make it symmetric over the y-axis. So if you have the graph that looks like this, right, then this and this will be symmetric, right? Another way to think about this reflection is if you had this graph and you drew it, and then if you flipped over this graph, if you flip it, then that's the other graph. Maybe I should draw it here. Just give me a minute. Suppose you have okay. So you have this graph, right? That's this brown graph that I just drew. Okay, and if you reflect over the y-axis, that means we are reflecting over this axis here. So we turn, and that's the graph that we get. Okay? All right, that's reflection over the y-axis. Right? So if we do that, then what is this new vertex? Yeah, so this -1 is now going to be over here, so it'll be 1. And the height doesn't change. It's still the same height, -1. So this coordinate will be 1, -1. And because the original blue graph is symmetric over the y-axis, reflecting over it won't change its shape. So all of these different parabolas are going to be exactly same shape, except that they're moving around in different places. Is that okay? All right. So now that means if I want the equation for this red graph, all I need to do is take the original blue one, move it 1 step to the right and 1 step down. That will be the answer that we're looking for. Okay. So I start with y = x squared. How do you make it go 1 step right? Replace x by x minus 1, yes. And then how do you make it go down by 1? Minus 1 outside. Okay, so that's the answer to this question, all right? Okay, so we kind of solved this question without need for any new kind of formulas or methods. But it does look pretty complicated, right? So let me try to simplify things a little bit. So I'm going to write this as solution 2. Now, even for the solution 2, the way you draw the graph is still the same. So this brown graph stays there. That doesn't change. But there's something different in the way that I'll find the reflection over the y-axis. And the way I do it would be to draw a very small set of x's. You know, this part is x, that's y. But then I'm going to mark some additional things. If this is x, this part would be -x. If this is y, this part would be -y. All right? So if you know that, then think about what happens if you flip it over the y-axis. If you flip it over the y-axis, where does x go? X goes to -x. Where does y go? Does it? It stays there, because if you do this, what's up there stays there. It just turns. It's still up, right? What was right became left. Left becomes right, right? So left and right changes. Up is still up, right? So we see that if you have y = x squared plus 2x, and if you do reflection over the y-axis, then y stays as y, whereas x becomes what? -x. So that's what we're going to do. Y stays as y, I don't change it. But every x I see, I'm going to replace it by -x. Now, one thing that you have to be careful is, whenever you do replacement, you need to introduce this parenthesis. Forgetting that would make some complications. Yeah, it's a given. Always, when you replace one by the other, always make it a habit to put parentheses, right? Okay, so if you put this parenthesis, let's see, what is -x squared? Just x squared, right? It's just x squared. How about this one? Oh, -2x. So -2x, right? That's the answer. Oh, wait, that doesn't seem to agree with our previous answer. What's happening? They should be the same. So let's check. What is x minus 1 squared? Yeah, or you can say square the first, square the second, which is +1. What happens in the middle? What do you do in the middle? No, no, I want you to say something that I said during the lecture. No. Square the first, square the last, and then not double the product. That was what I was using. Double the product. Double the product. Repeat after me. Double the product. Okay. I want you to say it that way. Okay. Right. Sure enough, like a minus b squared is a squared plus b squared then minus 2ab. That's not incorrect, but I like people to say double the product because it can be used in any circumstances. It's what's the product? X times negative 1 is negative x. You double that, what do you get? Negative 2x. So these two are the same. Okay, just like how we did here. X squared plus 2x plus 1 is same as x plus 1 squared, right? It's still the same. Double the x squared is here, 1 squared is here. You double the product, you get that. You get that? Okay. Just always remember double the product. And because of this, what is x minus 1 squared minus 1? X squared minus 2x plus 1 and then minus 1, and these cancel away, right? What is that? Same, right? It's exactly the same. So this method is easier to think and than trying to chase the vertex. Okay. So with this new tool, let's try to answer the following next question. Over. Okay, so let's think about this question. To solve this question, you first have to know that y equals the square root of x has this graph. Okay? It's a half of a parabola. That's the graph of y equals the square root of x, which you can obtain by just making a table of values of x and y. At some point, you will see that that's the graph. So we'll just accept that as given. That will be the common knowledge everyone should know. Now, first of all, how do you do reflection over y? Do you remember how to do reflection over y? We just did one. What was it? You do that, so what happens to the x? X becomes negative x. What about y? Y stays the same. So always draw this x, negative x, and y, negative y. You don't have to make this big. Just when you're taking the exam, make that symbol like small enough to fit in a corner of the exam paper. And you can use that over and over again. So we see that if you're doing reflection over the y-axis, then x becomes negative x, whereas y stays the same. So what that means is that y stays the same, but this x is replaced by negative x. Yeah. So you should put a parenthesis, but then a little later you see that there's no need for the parenthesis, so you remove the parenthesis. So that's the answer. What will be the graph of this? You have this, it's just, yeah, it will go that way, right? So the graph would be like this. Okay, and yes?
I guess I don't really have to ask the question, but are we going to be reflecting after, like reflecting over x after we reflected over y?
Oh, no. We'll just start from here and then reflect over, yeah. So these questions are reflecting the original one, not the series of reflections. Okay, now this is not part of the question, but nonetheless, it's good to ask what's the domain of these functions. What's the domain of this function? X is 0 or positive, right? Yeah, because you can't take the square root of negative numbers. Now over here, what's the domain? 0 or negative, okay? And if you think about it, it makes sense because if x is positive, then you have a negative number inside the square root, so it's not defined, right? But if x is negative, what is negative x? That's going to be positive, right? Did you get that? If x is negative, then negative x is positive. Is that okay? Yeah. So that makes sense only if x is negative. 0 is okay too, but positive is not okay. That's why the domain is negative infinity to 0. And that basically says that the graph should be going that way. You can't have anything on here. Okay? So that's another way to see why the graph will be that way. Okay, reflection over the x-axis. And this time, here's the x-axis, and you're doing this, right? You're flipping over that way. So x goes where? X stays, okay? What about y? Y becomes negative y. So what you have is, here you take the original graph, y equals the square root of x, and then y has to become negative y, whereas x stays as x. So you have negative y equals the square root of x. Now normally when you write down the equation of functions, you always solve for y, so you don't write it this way, you would write it as y equals to negative square root of x. So that's the graph that we're getting. That's the equation that we're getting. What would be the graph? Right? So what's the graph? You had the original as this, you flip it upside down, that's going to be the graph. Okay? All right. Now the last thing, reflection over the origin. This one we haven't done anything like that. I haven't explained. So let me first give you an idea of what a reflection over the origin is. So if you have any point on the plane, the reflection over the origin of this point is like you have to draw a straight line to the origin and take the same distance, and then this point now will be the reflection of this point over the origin. Okay? That's how you do point reflection. Now at first, that seems a bit complicated, but it's not that hard if you see that this is nothing else than first reflecting over the y-axis and then x-axis. So if you take this and reflect over the y-axis, where does this go? It goes over here, right? And then where does this go if you reflect over the x-axis? You'll flip upside down, it'll go here, right? So if you do reflection over the y-axis and then x-axis, that's same as reflection over the origin. And you can also do it the other way too. You can first opt to reflect over the x-axis and then y-axis. Doesn't matter. In any order, you end up with the reflection over the origin. And if that's what it is, where would x go if you reflect over the origin? Negative x. Where would y go if you reflect over the origin? Negative y. So because you're doing both, you're doing reflection over the y-axis and also the x-axis, they both change. X becomes negative x and y becomes negative y. Is that okay? Does that make sense? Okay, so you're going to get, starting from y equals the square root of x, it's going to be x becoming negative x and y becoming negative y. So the end result is that you have negative y equals the square root of negative x. Again, you want to solve for y and write down y equals to negative square root of negative x. Okay? So that's the equation. It's very tempting to say, oh, negative is plus, but that's not true. Okay? You can never bring this negative outside. That's a big no-no. It's inside the square root. Nor can you put this inside. Those are not allowed. Okay, so these negatives can't be going anywhere. It has to be there. This is the simplest way you can express it. Now, what is the graph, though? Well, that's same as reflection over y and then reflection over x, right? So you can take this one and reflect over the x. What graph would you get? Like that, right? So that would be the graph after reflection over the origin. Okay. Do you have any questions? Okay. Now, there's the final type of reflection, which is a bit more complicated. Can you draw the line y equals to x? What is that? It's a straight line 45 degrees slanted to the right, right? So passing the origin, yeah, it's this line. That's y equals to x. And you can think about the reflection over this blue line. Okay, you can do reflection over this blue line. Now let me see if you can figure this out. This is a question you can figure out without learning anything. If you have this point 2, 1, and if you reflected this point over the blue line, what would that be? Yeah? 1,2. Good. Do you see it? Yeah. You should be able to see it. Just by carefully drawing it, it's easy to see that 2, 1 should go over here. Yeah, just first of all, make sure that you understand what I mean by reflection over the blue line. I'm doing this, drawing this, and flipping it that way. Right? So what's over here is going to be flipped over to be here. You see that? Yeah. So this is going to go over here. And then if you look at it, well, it's going to be 1 and then 2. So 2, 1 goes to 1, 2. In general, if you have A, B, where would that be sent to? B, A, right? B, A. So the reflection over the y equals to x is going to send A, B to B, A. In other words, x and y coordinates will be switched. That's what this reflection does. Okay. Now, in terms of this small graph, what's happening is, think about this blue line. If you flip that way, where does x go? X goes to y. If you flip that way, x moves to y. Do you see it? Okay. Where does y go? Y goes to x. If you flip that way, y goes to x, right? So it switches like that. X becomes y, y becomes x. In other words, to do the same idea of like drawing something and rotating, what you're doing is you're taking this and here's the 45-degree line and you're doing this. Okay? That's what reflection over y equals x does. Okay? So the reflection over the y equals to x. So example 3. What is the equation of the graph obtained by reflecting y equals to x squared over y equals to x? Sketch the reflection as well. Okay, so finding the equation part is now easy. Right? You have y equals x squared, and you reflect over y equals to x. What's the idea? X goes to where? Y. Where does y go? X. So this y, what do you write? X. This x, what do you write? Y. Okay, this time it's not easy to solve for y, so we'll just leave it like this. So that's the equation for the, so originally y equals x squared is this, right? So that's y equals x squared. And then x squared. And then now your task is to take this blue graph and flip it over the red line. Now, okay, so I do this a lot in all of my Math 90 classes, and it's kind of amusing how many people don't get this. It's like, it's such an easy geometrical question, which you don't really need to learn anything. It's like reflection, anyone should be able to do, right? But then I think one is that a lot of you are not careful. A lot of you are just careless doing things. It says, don't think deeply of something and just write something and expect it to be right. And you expect me to give you some partial credit. No way, okay? Yeah, they'll be just flat out wrong. Another thing is that some of you have the attitude like, I've never been good at math, and this is math. The moment you hear that this is math, it's like, I'm not supposed to be good at this. It's like, it's nonsense. This is something anyone can do. Just look, we're flipping over this way, right? So think about it this way. If you do it, if you fold it along the diagonal like that, right? And then if you open it up, what's the answer? This is the answer, okay? Yeah. So, of course it should work every time. What are you saying? It's obvious, all right. It works every time, okay? It works every time. So that's the graph, okay?